The distance between 2 points is the length of the line segment formed by the points. When the distance between the points is required, it can be found by substituting the coordinates directly into the distance formula. We start by labelling the coordinates of A as x1, y1 and B as x2, y2. These values are then substituted directly into the formula as required. Another method of finding the distance between 2 points, if we are given them plotted, is to use the Pythagoras Theorem Equation. On the given Cartesian plane, we would construct a right-angled triangle with the line segment AB as the hypotenuse. Using the Pythagorean triple, the length of the hypotenuse is C, and the horizontal and vertical lengths are A and B. The side lengths can be read directly from the axis and substituted into the equation. The hypotenuse length C can then be found, which is the length of the line segment AB. We will practice both of these methods later. In this practice question, we must find the distance between the points A, 2, 3 and B, 5, 7. As we have the coordinates of the 2 points, we can use the distance formula. We start by labelling the coordinates x1, y1 and x2, y2. Next, we substitute the values into the formula as labelled. At this stage, you can enter this directly into your calculator to find the answer. But in this example, I will go through it step by step in order to revise some maths rules. We will start with the BIMDAS rule, which determines the order of operations. Each letter stands for the operation which must be carried out in its order. In this question, we do have brackets, so their contents must be simplified first. Next is indices, which is the power of 2 here. Next in this question is addition. And the last part is finding the square root, giving us an answer of 5. Therefore, the distance between the point A and B is 5. In our second question, we need to find the length of the line segment AB that is shown on the graph. We have 2 options here. One option is to find the coordinates of A and B and then use the distance formula. The second option is to use Pythagoras Theorem Equation. As we have the graph, we will use Pythagoras. To start, we construct a right-angled triangle with the line segment AB as the hypotenuse. The length of the horizontal side can be read directly from the x-axis, where the length of A is 4 minus 2. The vertical side is read directly from the y-axis, where the length of B is 4 minus 1. Substituting these values into the equation gives us c squared equals 2 squared plus 3 squared. Simplifying gives us c squared is equal to 13. To find c, we must get the square root of the other side. So c is equal to the square root of 13. In this question, we do not need the plus or minus, as length is always positive. Therefore, the length of the line segment AB is the square root of 13. In this question, we are given the distance between points A and B as 5 units, but one of our coordinates contains an unknown k value. In this type of question, we will use the converse of the distance formula. We will start by substituting everything into the formula as normal. The result is known as a surd equation, as we have a square root function over a variable. To solve a third equation, we must square both sides of the equals and then simplify. The square of a square root removes the square root function. We must now simplify our equation in order to solve for k. The brackets containing k minus 3 is squared, which means that k minus 3 must be multiplied by itself. We can multiply these two brackets using algebra rules, or we can use the expansion formula. Here we will practice the formula. So k minus 3 to be squared is equal to the first term squared plus 2 by the first term multiplied by the second term plus the second term squared. Bringing it all together, we have 25 is equal to 3 squared plus k squared plus 2 by k by minus 3 plus minus 3 to be squared. We can now tidy up each part. Now we must rearrange the equation, putting all terms on one side of the equal sign. We now have a quadratic equation, which we must solve for k. There are two methods for solving quadratics, either factorization or using the root formula. Here again, we will practice the formula. We will substitute the coefficients from the equation in the formula for the letters a, b, and c, where a is the coefficient of k squared, b is the coefficient of k, and c is the constant. We now substitute them into the formula. This can be put directly into your calculator, first with a plus sign, and then repeating by changing to a negative sign. The k values of 7 and minus 1 will be the results. Well done! We have completed the theory section of the module. We can now practice exam level questions. When each question appears, you can pause the video and attempt a question. Don't be afraid of making mistakes. We learn more from our mistakes. When ready, press play again, and you will see the question fully worked and explained. In this question, we are given 4 coordinates A, B, C and D, and we are told that they are the vertices of a rectangle. We are asked to show that the distance from A to D is root 5 units. As we are given the coordinates of the points A and D, we can use the distance formula. We start by labelling the points x1, y1 and x2, y2. We can now substitute them directly into the formula. Using a calculator, we find that the distance is root 5 units. Here we are given the coordinates of 3 points A, B and C, which are the vertices of a triangle. We are asked to find the distance from A to B, which is the length of the line segment AB. We are also required to give our answer in the form A root B, where A and B are natural numbers. Natural numbers are whole positive numbers. As we are given the coordinates of A and B, we can use the distance formula. We start by labelling the points x1, y1 and x2, y2. We can substitute them directly into the formula. Using our calculator, we find that the distance from A to B is 2 root 13 units and is in the format required. In our last question in the module, we are given the coordinates of the points A and B, and we are asked to work out the distance from A to B. As we are given the coordinates, we can use the distance formula again. We start by labelling our points and then substituting them directly into the formula. Entering this into a calculator, gives a result of 3 root 5 units.